We're going to be looking more in depth at infinite limits and limits at infinity. We've talked about these.
Sounds good. Let me edit this real quick. Edit this. So update. Yeah. All right. Oop. That's the wrong one. All right.
Before from an intuitive standpoint, and we're going to continue with the intuitive view of a limit here. Later, at the end of this chapter, we will discuss the formal definition of a limit, and we'll get a little bit more precise about what exactly the limit is mathematically. For now, though, we'll stay with the intuitive version. This section is actually out of section 4.6. The textbook covers the limits at infinity and infinite limits later than I'd like, so I always move this section of 4.6 forward. There's another part of 4.6 that we'll cover later on. Let's
infinite limits and limits at infinity. Oh, maybe if let me see what it looks like on the webcam. Let's see what you still don't see. Try now. Yep. Alright. Alright. Let me Alright, let's
talk first about what exactly an infinite limit and a limit at infinity is. An infinite limit is when the y value is going up forever without bound. So for example, right here, you can see the y is going.
Watch this whole thing, bro. Oh, what is this? How long is this?
For the function f whose graph is given, state the following. The limit as x approaches 2 f of x. Okay, looking at the graph, let's find out where x equals 2.
1, 2.
On the x-axis, here's 0, 0. So this is the x-axis. Here's 2. We're going to have to look at the limit as x approaches 2 from the left. So as x approaches 2 from the left, our graph is approaching infinity. As we look at the limit as x approaches 2 from the right, our graph also approaches infinity. So our limit here is infinity, since the limit as x approaches 2 from the left of f of x is equal to the limit.
What's part B then?
For the function f whose graph is given.
Okay. Let's sneeze. I can't sneeze. Sketch a function of f that satisfies all conditions. As x approaches 2, it goes negative infinity. So 2 from that was just 2. It's gonna have to do one of these now. As x approaches infinity, x approaches infinity. 1 gets to infinity. Here's this one. Net. Let's see. Infinity. 0. What the hell? I'm tweaking. All right, as x approaches 2, I'll just draw it out for myself. Say, got this, here's 2. Have to go negative infinity. As x approaches infinity, y approaches infinity. Something like this. Like this, I think. This probably honestly might be second one. Alright, whatever. X approaches 0. As y approaches 0. As x approaches, oh, wait, 0 from the left. Or no, 0 from positive, it's up. No, am I tweaking? Like, please tell me I'm not that dumb. Ah, thank God. Thank God. Alright, let's see. Let's watch this one.
Evaluate the limit and justify each step by indicating the appropriate properties of limits. For the limit as x approaches infinity of 2x squared minus 7 over the quantity 5x squared plus x minus 3. As x approaches infinity, both the numerator and denominator approach infinity. So it's not immediately obvious, and this will obscure what happens in the limit. So we can divide both the numerator and denominator by the highest power of x that we see in the denominator, which is x squared.
So we're taking out that. Divided by x squared.
So when we do this, the limit becomes the limit as x approaches infinity
As x approaches infinity
of 2 minus 7 over x squared in the numerator, divided by
over
5 plus 1 over x
1 over x
minus 3 over x squared in the denominator. So we can next evaluate
makes sense.
this, knowing the property of limits, that the limit of a ratio is a ratio of the limits. So this becomes the limit
the hell?
as x approaches infinity of 2 minus 7 over x squared in the numerator over the limit as x approaches infinity
So,
of 5 plus 1 over x minus 3 over x squared in the denominator. So next we'll separate this out a little further by evaluating the numerator and denominator. And we know that the limit of a difference, or the limit of a sum, is equal to the difference of the limits, or the sum of the limits. So the numerator becomes the limit as x approaches infinity of 2 minus the limit as x approaches infinity of 7 over x squared.
Pause. Time out. X approaches infinity. The limit of x approaches infinity of 2 minus the limit of x approaching infinity.
Over the limit as x approaches infinity of 5 plus the limit as x approaches infinity of 1 over x
1 over
minus
x.
the limit as x approaches infinity of 3 over x squared. Okay, so let's take this a step further, and we'll look at the constants. And the limit of constant is constant.
How many steps are we taking, bro?
As x approaches a number, the constant times a function is the constant times the limit of the function. So let's evaluate that. And our function becomes 2 minus 7 times the limit as x approaches infinity of 1 over x squared over 5 plus the limit as x approaches infinity of 1 over x minus 3 times the limit
minus 3
approaches infinity of 1 over x squared.
Oh my days.
So the next step is to evaluate
what? How many steps?
Inverse functions of x, where x can be raised to any power. And we know that the limit as x approaches infinity of the inverse of x to any power is equal to 0. So we can simplify this as 2 any x, where x can be raised to any of 1 over x minus 3 times the limit as x approaches infinity of 1 over x squared. So the next step is to evaluate the limits of the inverse functions of x, where x can be raised to any power. And we know that the limit as x approaches infinity of the inverse of x to any power is equal to 0. So we can simplify this as 2 minus 7 times 0 in the numerator.
Oh, wait, now we're subbing stuff in, right?
Over 5 plus 0 minus 3 times 0 in the denominator. So all the 0 terms drop out, and this gives us 2/5.
Yo.
So to summarize, we simplified this function. We started by dividing both the numerator and the denominator by the highest power of x in the...
Bro, we got... You can't summarize this in 10 seconds.
...denominator, and then applying the limit laws. And in doing this, we were able to find the limit of the function as x approaches infinity as 2/5.
How does the video end there, bro? What the hell? Alright, let me get my eraser. Actually, I'll keep this out for now. So I've got limit as x approaches infinity. 4x squared minus 5. 3x squared plus x minus 3. Alright, and then split squares into both. Take out the x squared. Take the x squared. That's literally as far as I freaking understood all my days. Alright, well, the 4 is like this, minus 5 over x squared, I think, over 3 plus 1 over x minus 3 over x squared, I think. Holy shit. I mean, that looks right so far. 1, 3. Son. Matches up. Matches up. Alright, so we're right here. Did that, did this. Did this. Third step is now do a lim on the top and the bottom. Lim as infinity on the top over lim as x approaches infinity on the bottom. Did I just drag everything down? Let me look at this tutorial, bro.
Evaluate squared in the numerator over 5 plus 1 over x.
Alright, this is where I'm at right now. Except for the other problem. Alright. So all she do is just bring the whole thing down with the limit on top and limit on the bottom. X squared, and then 3 plus 1 over x minus 3 over x squared. So now here, in this part. Oh, what? Do we just... How did she go? Oh wait, this is a 2 though. 2 minus limit as x approaches infinity, 7x squared.
Evaluating the numerator and denominator, and we know that the limit of a difference or the limit of a sum is equal to the difference of the limits or the sum of the limits. So the numerator becomes the limit as x approaches infinity of 2 minus the limit
2 minus the limit
as x approaches infinity of 7 over x squared.
So then she's putting this next to this and this and this. Alright, hold up, let me do that real quick. The limit, oh, that's agreed. Limit is x approaches infinity. Oh, this is, I have 4 though, of 4 minus limit as x approaches infinity of 5 over x squared over lim as x approaches infinity 3 plus lim x approaches infinity of 1 over x minus lim x approaches infinity 3 over x squared. I think.
Over the limit as x approaches infinity of 5 plus the limit as x approaches infinity of 1 over x minus the limit as x approaches infinity of 3 over x squared. Okay, so let's take this a step further, and we'll look at the constants. And the limit of constant is constant. And the limit as x approaches a number of a constant times a function is the constant times the limit of the function. So let's...
Oh, that's an ick. Fuck.
And our function becomes
I'm sick.
2
I'm sick, bro.
minus 7 times the limit.
Hold up, what is she doing now?
As x.
2 minus limit.
X approaches
2 minus 7.
Infinity of 1 over x squared.
She took out the 7. How'd you do that? So you're dividing. You multiply by 5. It cancels out. She's like doing some voodoo, bruh. Okay, so then what I can do is 4 minus, you're just moving it over, minus 5 of the limit as x approaches infinity over 1 over x squared over, you have to do it for the 2 on the bottom though, not thinking about it. Okay, actually I don't even know how you're gonna do that.
Over 5 plus,
so it's just 3.
The limit is x approaches infinity of 1 over x minus 3 times the limit as x approaches infinity of 1 over x squared.
Alright.
So the next step is to evaluate the limits of the inverse functions of x, where x can be raised to any power. And we know that the limit as x approaches infinity of the inverse of x to any power is equal to 0. So we
whoa, run that back, Turbo.
To any x squared minus 3 times the limit as x approaches infinity of 1 over x squared. So the next step is to evaluate the limits of the inverse functions of x, where x can be raised to any power. And we know that the limit as x approaches infinity of the inverse of x to any power is equal to 0. So we can simplify this. Infinity of 1 limits of the inverse functions of x, where x can be raised to any power. And we know that the limit as x approaches infinity of the inverse of x to any power is equal to 0. So we can simplify this.
Oh man, I was gonna get used to that.
As 2 minus 7 times 0 in the numerator.
So for me, this is just 4 minus 5 times 0
over 5
3
plus 0 minus 3 times 0
times 0 for me as well.
In the denominator. So all the 0 terms drop out, and this gives us
4/3. That's what I end up.
2.
Well, so it's just 4 over 3. Feel a little bit accomplished, can't lie. Oh my god. Oh, I missed the first one. Oh, why do we have to do freaking? God damn, how long is it gonna take me?
Find the limit or show that it does not exist of the limit as t approaches infinity of.
Oh my god. Oh, I'm gonna be doing math all day. What? Lim is t approaches infinity over square root of t plus t two minus t squared. There's got to be a faster way to do this. Let me call up my boy. Is he in call? Oh, he's probably in call, isn't he? No, he's not. All right, let me call him up. This should call WebAssign. All right. Hello. Yo, do you do your homework through WebAssign?
My math homework, yeah.
When you like do it, right? Like, so far I've only got like different problems. Like, do you how do you learn it? Do you actually watch the video at top, or like, and how many questions do they give you, bro? Because why do I have 16 questions to go through, bro?
I usually get like 12, I think.
12.
And then some questions have multiple parts, so it ends up being close to like 20.
How long does it take for you to do a homework?
It depends how I'm doing it. Because if I'm trying to learn everything first, I usually take like 2 hours to go through like videos and then do the homework, and that's like another hour and a half or something. And then for my Unit 3 homework, it was 18 questions. And I literally took the questions, GPT wrote down how they worked and like how to do them. And then I'm just kind of studying that.
Do the videos help half the time or not?
Sometimes the videos are good for like if you watch like one video, at least for me, one video is good for like 1 or 2 concepts homework, but it's not good for all of the stuff that I have to do for the homework. So I'll have to sometimes watch like 2 or 3 videos, or even then, sometimes there isn't even a video on some of the stuff I'm supposed to do on the homework. So I just have to like GPT it and then learn how to do it there.
Alright, that's good to know.
But usually it's like 2 to 3 videos that I'll watch.
Jesus Christ! What the hell?
And that's what happens when you take an asynchronous class and you gotta do the work twice as fast.
This is actually freaking hell, bruh.
It's preparation for next semester, bro. Next semester will be the ultimate weapon, bro.
I'm saying this actually like might make my next semester easier because this is just so buns, bruh. And you're taking 3 classes, but like still, holy. Alright, I guess I'll just trudge along, bruh. Holy fuck. Alright. Hey, but I'm knocking out 2 birds with 1 stone. I'm streaming my math homework, bro. Is this method, bro?
Are you serious?
I'm being dead ass.
Who is watching it?
Let's see. 0 viewers, bro.
Okay, right. I'll tune in on my PC. I gotta do my exam on my laptop.
So you got that today, right?
Yeah.
All
I'm
right.
studying. Well, I'm taking a shit right now, but I'm studying.
All right. I'll see you, bro.
All right, see ya.
So we freaking got the homework of doom and despair, bro. Can't be dead ass. Oh. Next one, I guess, bro.
The quantity square root of t plus t squared over the quantity 2t minus t squared. So let's start by evaluating this and dividing by the highest power of t found in the denominator. So we'll divide both the numerator.
You know, I understand this now. I understand it now. I understand this now.
By t squared, which gives the limit as t approaches infinity of square root of t over t squared becomes t to the negative 3/2.
What? Oh, because, yeah, don't you put the... Let's see, if you do a square root... Wait. That makes sense. Two over two now. How did we get the negative 3/2?
Found in the denominator squared, which gives the limit as t approaches infinity of square root of t over t squared becomes t to the negative 3/2.
Just don't get that.
Plus.
Is it just 1?
T squared over t becomes 1 over 2t over t squared becomes 2 over t minus t squared over t squared becomes 1. So let's rewrite this as the limit as t approaches infinity.
Too much teas, bro. I'm thinking about tung sahur, bro.
To the 3/2 plus 1 over.
Where the hell did we get the 1/2 from?
2 over t minus 1. So we can simplify each term of the numerator and denominator by recognizing the property of limits, that the limit of a function, restate, the limit of a sum is the sum of the limits, and the limit of a difference is the difference of the limits. So this becomes the limit as t approaches infinity of 1 over t to the 3/2.
Fuck.
Plus the limit as t approaches infinity of 1 over the limit as t approaches infinity of 2 over t minus the limit as t approaches infinity of 1. So we also know that the limit of a constant is a constant, and we also know that the limit as t approaches infinity of 1 over t raised to any power
0
approaches 0. So this becomes 0 plus 1
0 plus 1 over
0
0
minus 1.
Oh, minus 1 does not exist. Wait, positive 1.
Which becomes negative 1.
Negative 1, never mind. I'm slow. I gotta blow my nose. My days.
And then which
I
became
hate you, math.
negative 1.
I hate you, man. Oh my god. That's why. There we go, pen. So down here, I've got lem, st, approaches. No. Infinity. Square root of t plus t squared over 8t minus t squared. Fuck. That'll make me think about Tumbra. Oh my gosh, my eyes itchy. Oh my gosh, I'm tired, bro. I can't do this. So you take out the t right here. Take out the highest power. I guess we gotta freaking ask. Oh! Right. We'll talk about that. Oh. This might be important. Let me mute real quick. It wasn't important, guys. We're good. We're good. Oh, I was gonna ask it. Why? You guys don't understand. This is my calculus. This is my calculus, buddy. y in calculus. It's kind of obnoxious. I might have to switch this. Oh, so I just have that sound effect still. How do I check keyboard sounds? Ooh. I look like that one. Actually, I don't like it. Yeah, I'll probably just do this. You can barely hear my shit. T does the square root of x become Alright, let's hope it understood what I was trying to say. Yeah, that's tough. I like this one. Oh, I'm gonna get copyright strike for this, aren't I? Sorry. Okay, I understand this. Okay. It's a classic algebraic move that pops up all the time when you're trying to write a tricky fraction into a simple line. So we can easily apply the power rule to find the slope of the tangent line. Okay, that is in fact the expression I'm dealing with Gemini. Let's see. Okay, let's get a fraction from. You must need to combine two fundamental rules of exponents. Here's a step-by-step breakdown. First, you need to speak to the same language. A square root is mathematically identical to an exponent of 1/2. Okay. So I'll just make these equal to t to the 1/2. Oh, alright. It's holy crap, I hate my nose, bro. I hate being stuffy. Pause. Let's do the back in your fraction. That's literally all it is, huh? You just put a 1/2 over it, and then it t 1/2. 1/2 minus 2, because you know we got the 1 on the bottom. That just, yeah, okay. I understand it now. Thank you, Gemini. 3 over 2. And I forgot how to do the rest of the problem. Jesus Christ. Oh wait, this is gonna be +1. And at over t squared. What does that give me? It should be 8 over t. Alright. Okay. Minus 1. Oh, and then the infinities just apply to both because we have the freaking infinity rule for no reason, bro. What is your rule? I think
0 minus 1.
Hold up. Oh! Hold up. It's 1 over t. Doesn't make sense. It's basically subtracting Oh my god. This is terrible, bro. Holy, I hate asynchronous. Why did I take this class, bro? Oh my days. This is equal to 0 plus 1 over 0 minus 1 equal negative 1. Okay. Good to go. Good to go. Oh my gosh. Right. Oh. Oh, crap. I'm upside down. Ooh. It was correct. God damn. This is slow. Why are you teaching me so many concepts? Oh my gosh. Yo, I'm in hell. This is hell.
That it does not exist. For the limit as x approaches infinity of the square root of x.
Let me box these up so I just know how to differentiate which ones I'm doing. This is like its own. Oh, I'm gonna have to zoom this out even more. Jesus. Yo, I bet it looks like a whole bunch of bullshit right now. I'm trying to make this box nicer so I can use it for my notes later on. But it looks like I'm just doing a whole lot of BS, bro. Alright, let me circle this up. Move this here. Perfect. Move this up. Perfect. Alright. Let's go! Let's go! Next one. As x approaches infinity. Over square root x plus 3x squared 4 x minus 1.
3x squared over the quantity 4x minus 1.
Alright.
So we'll start by dividing both the numerator and the denominator by the highest value for the
they both have, so they both have
power of x found in the denominator. So we start by evaluating the numerator in the limit as x approaches infinity. And we know that the square root of x squared is equal to x. So we'll bring x squared, or the inverse of x squared, into the root. So limit as x approaches infinity of the square root of x over x squared becomes 1 over x, plus 3x squared over x squared becomes 3.
3x.
Then the
3x.
numerator
On the back,
4x
Turbo.
over x squared becomes 3. Then the
3x squared over x. How does 3x squared over x become
the numerator becomes 4x over x equals 4.
4x over
minus 1 over x.
X. 4, yes.
So next we'll start to look at each of the terms in the numerator and denominator and break them down using
this doesn't make sense. It's just one. Is it because of the square root? What does the square root do in that? How does the square root interfere with this problem, bro? Oh my gosh.
The limit laws. So we know that the limit of the root is the root of the limit, and the limit of ratio is the ratio of the limits, and we can break this down.
Yo, you just said a whole bunch of gibberish, bro. What?
That. Property of limits. So in the numerator, we have the limit, or the square root of the limit as x approaches infinity of 1 over x plus 3. And in the denominator, the limit as x approaches infinity of 4 minus 1 over x. So that next we can break down each of the terms, since the limit of a sum is the sum of the limits, and the limit of a difference is the difference of the limits. So we get the square root.
I don't know what you're saying.
Of the limit as x approaches infinity of 1 over x plus the limit as x approaches infinity of 3, square root of that, divided by the limit as x approaches infinity of 4 minus the limit as x approaches infinity of 1 over x. So next we can evaluate these terms.
Oh, I'm going insane.
And we know that the limit as x approaches infinity of 1 over x raised to any power
0
is 0. And the limit of a constant is a constant, regardless of the limit.
Constant. So is it just 3 over 4?
So we can evaluate those
square root of
terms.
3.
Numerator becomes the square root of the limit as x approaches infinity of 1 over x becomes 0, plus the limit as x approaches infinity of 3 becomes 3, over limit as x approaches infinity of 4 becomes 4, minus limit as x approaches infinity of 1 over x becomes 0. So this becomes the square root of 3 divided by 4.
Cut the cameras, bro. Cut the cameras. Cut the cameras. Oh my god. I'm gonna lose. I'm gonna lose, bro. I'm gonna lose. So let me start playing. Oh my god. Oh. Okay. What the hell? 2x squared God, I'm so sick, bro. My throat hurts. Alright. Just evaluate 2. Take out the highest power first. Highest powered here. It's 1 over x. Right. Why is it 1 over x? It's 1 over x, right? It is. Plus this is just 2. I think I'm gonna understand why it's just 3 on its own now, but whatever. Then it's now 4 over x, right? 4 minus. Wait, what? Oh, it is 4. 4 minus 1x. Alright, and then they put in the limit, right? Yeah, that's what they did. Lim x approaches infinity. 1 over x plus lim x approach infinity 2 over lim x approach infinity 4 minus. Wait, why is it 1 over x? Minus lim x approach infinity. Gang. Oh, minus 1 over x. Which now becomes, well, 1 over x 0 plus 2, so all square root, over 4 plus 0, which is square root of 1 over 2, which I think is just 1/2. It's gotta be 1/2, bro. Oh, I'm gonna lose. I'm gonna lose. I'm gonna lose. God! Why is my freaking... I forgot my binder set to that, bruh. Holy crap, I would rather be doing anything right now than this crap, bro. Holy... Oh, fuck. There's no way it's been an hour already. It's been an hour. I'm sick. Can't think. Well, I know I'll be doing a little bit of a research. Understand. Okay, that's straight bullshit. What the hell? think I did right for the most part. I just don't know what they went wrong with it. Oh. Oh my gosh, I'm about to fall asleep. Turn off the fan. We're gonna have to get some music going, bro. I'm actually gonna fall asleep, bro. Holy. They made a fearless, bro.
I show my team if you want to win.
There's no way. Let's get Bleach OSD going, bro. It's a sad one. Is it? I went too far. Got it right, but at what cost, bro? I'm not even a fourth of the way through. Oh, I actually am. I'm a fourth of the way through, Evan! I'm not even all the way done. I'm a fourth of the way through. It's taking me an hour. Is it gonna take me 4 hours to do this? What do I do? This calculus shit ain't built for, I'm not built for this, Evan. Cause you remember all this, bro. Oh my god, I'm gonna lose. I don't remember any of this from last year. Cause I was tunging my sahur, bro. I was tunging my sahur in high school, bro. Not in class, guys. Don't take that up, man. But I don't know who's gonna see this. I was not actually doing that. But I was not doing shit senior year. And it's all different. It's all different variations. They gave me. Hold up. That's why I did get first place on the AP exam. Y'all got me beyond that. Anyways, first one I hear. We do. It's the. I remember this one. I remember this one because in the high school it was easy. It's literally just you look at the first two and that was it. All right. But then the next one, they're giving me a square root in the top, so it's a whole different. I gotta watch a video on it. Third one, square root of the whole thing. Now I gotta watch a new video on it. Fourth one, there's no bottom anymore, bro. Fifth one, now I've got the freaking unit circle values, arctan, bro. Sixth one, now we're implementing E. Seventh one, ln, logarithms. Eighth one, holy fuck. Go back to the fourth one. This is the fourth one. Oh my god, I'm gonna be here until 7, bro. I'm actually gonna be here until 7. when there's no denominator. Oh, this one. Bro's about to drop me some lore. But bro's about to drop me some elite ball knowledge. Oh, this motherfucker's just doing it for the love of the game. I can already feel the gears turning in his head, bruh. He's already freaking... Oh, wait. There's some trick, though. Because 7 times 7 is 49. They wouldn't have this here for no reason. They wouldn't have a... I understand their ways, bruh. I understand how it works. I'm a lazy genius. I'm actually a lazy genius, guys. I'm a lazy genius. What? Let me just... I don't know how long you want me to be here for. Let's see what else there is. Okay. I'm gonna go insane. There has to be a video or something that covers all of it. Yeah, there is, but the video's an hour.
We're going to be looking more in depth at infinite limits and limits at infinity. Negative infinity as x goes to this.
Actually, it doesn't even go over the problems.
That means that when this problem, the limit as x approaches infinity of the ratio of 3x squared plus 2x minus 1 to a denominator of 5x squared minus 4x.
Okay, but I already spent an hour knocking out 4 problems. Am I really going to spend an hour watching the video and then spend like 4 more hours doing the problems, bro?
7 approaches is not equal to...
You don't even get... Oh.
Don't put equals.
I guess I'm lucky.
Arrow approaches the graph of 3x squared over 5x squared. The highest degree term in the numerator.
Oh my gosh. Yo. Example 4. Is this the one I did earlier? 3x squared plus 2x squared minus 1. 3x squared. Oh, well, that was, yeah, literally the 3/5.
The denominator.
You're spending that amount of time because you're trying to learn each individual question and not the actual concepts type shit. Alright.
Don't forget to...
Well, honestly, it looks like the first 40 minutes are straight bullshit, bro. I mean, what are we doing here? You got 2 hours. Go watch Professor Leonard. I want to play some video games. I don't want to do math for 2 hours, bro. I don't want to watch and then learn. Larp night. Larpless. Professor Leonard. Oh, he look kind of tough though. I can't hold you, bro. He's been gone for 3 years, bro. Oh, courses. Oh, yeah, you're right. Calc 2, Calc 1.
Well, welcome to the official start of calculus. Congratulations, you made it in the class. Today we're going to talk about a review of a lot of the Math 2 concepts and some basic algebra concepts that you really need to have down in order for you to be successful in calculus. The first place we're going to start is section 0.1, chapter 0.
Where am I at? Am I like number 2? Just go to the limits video.
So we've just talked about lines. We're going to be a little bit more general.
There we go.
So let's get started with our actual calculus stuff. Oh, this is going to be awesome. So with our calculus, we're going to talk about limits first. Now, our limits is really the basis to our calculus. It's how we do calculus. We're going to find out some kind of tricks to calculus later, but for right now, if you know how to do limits, you're going to be able to do calculus. So it's probably a pretty important idea, yeah? Yeah. So we're going to find that out towards the last part of this class. For right now, I want to lead you through an introduction to calculus and what it's all about. Are you ready to learn that? So review is over with, thankfully. Now we're going to slow down just a little bit. We're going to talk about actual calculus stuff. So no more really hair-raising, kind of, oh my gosh, so much stuff. We're going to go a little bit slower, but it's going to be more in-depth. You ready for it?
Yes. I said yes. Slower pace sounds good.
Slightly slower, not much slower. In calculus, we have two basic goals in Calculus 1, this introductory course of calculus. So here's our two goals. Goal half of our class on is this goal. Given any curve, not straight lines are easy, but given a curve, I want to be able to find the slope of a curve at a point. Isn't that an interesting idea? If I say to you, I want you to go ahead and find me the slope at that point. Right now, we really have no idea how to do it. I mean, you can approximate it. You can go, oh, okay, I'll find you slope. Let's see, slope is 1/2. Is that accurate? No idea. Right? Well, we can't really just kind of approximate slope. What we're going to do is find out a really good way using calculus on how to find the slope of a curve at a point. In fact, when I ask you a certain thing in this class, you're going to say, oh, it's the slope of a curve at a point. We're going to talk about that for a long time. That's goal number 1.
My thing was just limits to infinity, or limits, infinite limits, and limits at infinity. Separate video.
We gotta start with some basics. Is that 1.2 or 2.2? 1.2. We're skipping a chapter and
I was going, uh-oh, we're in trouble now.
yeah, I'd like you to read the rest of chapter 1. You know, just kind of get it and then we'll be on. Suck. Some teachers do that, I've heard. Anyway, no, we're 1.2. My bad. I just like the number 2, so I thought I'd put it up there on the board. See what happens, you know.
Oh, whatever.
With this. Because that is an exponent, right? A radical is an exponent. You can remove a radical. I'm going to leave it like that. You can take a radical outside of your limit. We're going to do many examples of those things. But have those written down. We'll start with that next time. Well, if you remember from last time, what we're talking about is limits, and I think the last thing I did leave you with was the properties of limits. And there's a few things that we can do with our limits. Now one thing we knew was that from our basic limits, our little basis up there, the limit of a constant equals that constant. That was real nice. Also, the limit of just a simple variable like x equaled whatever the x was approaching, that number. So those are the two basics I gave you, and then I gave you some properties. Basically, with our properties, it says you can split up limits by addition. You can split up limits by subtraction. You can split up limits by multiplication. You can also do it with division as long as the limit of the denominator is not 0. You can also, this is the coolest one I think, anytime you have a function taken to a power inside of a limit, you can take the limit of the function and then take the power afterwards. So that means you can really alleviate the problem of having an exponent within any limit. Are you ready to see how we can do that to evaluate that limit without doing those silly, like, check a 2 in the middle and then find out from the left and from the right? Remember doing those, right? Those tables? We don't want to do that anymore. We want to use the properties and our basis for limits to be able to solve this thing. You ready to do it? So here's what we can do. If we look at this thing and say, okay, limit as x approaches 2 of this function, the first thing I know is that I can separate limits by addition and subtraction. You with me? So what this says is, okay, well, this can become the limit as x approaches 2 of x cubed minus the limit as x approaches 2 of 2x plus the limit as x approaches 2 of 7. Now, a lot of people are going to ask, do I have to put the limit as x approaches 2 every time? Yes. Yes, you have to do it. It's like asking someone to take the absolute value. You have to write absolute value until you actually take the absolute
Oh my god, it's a 3-hour video. Alright, whatever.
Find the limit as x approaches infinity of the square root of 9x squared plus x minus 3x. The key to this problem is the square root. We're going to multiply by the conjugate. In the numerator and the denominator, so essentially we're multiplying by 1. The numerator's difference of squares,
I remember this.
so that will eliminate the square root. And notice the square root ends up in the denominator. Nine x squared in the numerator add out, so this gives us x in the numerator with the square root in the denominator. Now if we look at the problem,
Cancels out. Let's put that.
Can you open the door?
Can you go to the garage?
What are you doing?
Nothing. Oh, man. Jesus.
We're trying to find the highest power of x, and the highest power is 1, because in the denominator, the square root of x squared is x or negative x, depending on if x is positive.
So what's all this and this? With this one. We got square root 9 plus x. Let's see, multiply these two. That. So this canceling out.
Positive or negative. So we have to note that here, since x is going to positive infinity, that x is greater than 0, so the square root of x squared is x. So we're going to divide each term by x.
The heck? What are you both doing here?
Since our limit is going to positive infinity.
God. Oh my gosh. Multiply these two, which comes out to 9x squared plus x minus 9. So this cancels out. X over square root.
Now that's going to give us 1 in the numerator. It's going to allow us to bring the x inside the square root limit of x. So we have to note that here, since x is going to positive infinity, that x is greater than 0, so the square root of x squared is x. So we're going to divide each term by x. since our limit is going to positive infinity.
What?
Now that's going to give us 1 in the numerator. It's going to allow us to bring the x inside the square root when I change x to the square root of x squared. The square root of x squared, remember, is x. And then 3 plus 3 because the x's divide out. Now this is equal to the limit as x approaches infinity of 1 over the square root of 9 x squared over x squared plus x over x squared plus 3. That's the limit as x approaches infinity of 1 over the square root of 9 plus 1 over x plus 3. Now the limit of 1 over x, since x is going to infinity, the denominator is getting very large, that fraction is going to go to 0. So this goes to 0 when I take the limit, and now I have 1 over the square root of 9, which is 3, plus 3, so our final answer is 1/6.
My fucking God. Jesus Christ. X. What does that even mean? Of course the square root of x squared is just going to be x. Oh my God. Oh. Okay. 3x over x just 3 cents. square roots cancel out. How long? I mean, hour and 40 minutes, bro. Yo, it's over. Focus. Oh my god. So you multiply this by its inverse. Top gets canceled out. It's become x. Just cancel that to be x. Over the bottom. Over the top. Divided over x, divided over x. Top becomes 1 over 49. That's just 49. $49 plus this would be the 1 over x, which is 0 minus 7. This is 42, 1 over 42. Keep on doing that. Oh my gosh. Oh, it's 1 over 14. Oh my gosh. Damn it! Keep on pressing that button. Oh. Find the limit. Where is the video, bruh? You've got to be kidding me. Arctan. What the hell is Arctan, bro? My days. Yeah.
Find the limit as x approaches infinity of 1 minus e to the power x over 1 plus 2 times e to the power x. We factor out the fastest growing term in the denominator from both the numerator and the denominator, which is e to the power x. So we have the limit as x approaches infinity of the quantity 1 minus e to the power x divided by e to the power x over the quantity 1 plus 2 times e to the power x divided by e to the power x. Simplifying, this is the limit as x approaches infinity of 1 divided by e to the power x minus 1 over 1 divided by e to the power x plus 2. Taking the limit of each of these terms here.
Okay.
Results in a contribution of 0. The limit of 1 over e to the power x as x approaches infinity is 0.
So negative 1/2.
And we're left with 0 minus 1 over 0 plus 2, which is negative 1/2.
So then for me, what is this one? minus 1 plus 7. 0, zeros out. Negative 1/7. Oh.
Find the limit or show that it
Is this W? Is this W Desmos? Is W freebie with Desmos? W Desmos freebie, bro. 4x squared plus x minus 1. Over x squared plus x. Oh, hell no. Five, 4. It's 3. The hell? Did I put this in right? 4x squared plus x minus 1. X squared plus x minus 6. Well, for your y values, it looks like it's freaking 4. Was this 3 and x squared minus x4. Okay. What the hell? That's infinitely approaching 1. Or negative 1. You mean? Am I missing something? Is 0 as well? Yeah, shit, alright. How many more problems do I have? 1, 2, 3, 4, 5. Jesus Christ. 6. It's infinity now. As x approaches negative infinity, y approaches, this is 2. What? No, this is infinity, I'm dumb. Why did every time there's negative infinity? It's negative 2. X approaches 1. Things effects is approaching infinity. 6 approaches 3. That's a negative infinity. Equations of the asymptotes. One, 2. Oh my god, okay, so. How the hell am I drawing asymptotes? Okay. Watch the video on how to.
For the function f whose graph is given, state the following. Limit as x approaches negative infinity, f of x The function f whose graph is given state the following, the equations of the asymptotes. Let's look at the graph to find the vertical asymptotes. We can see from the picture that we have a vertical asymptote here in red and also here
really
because 2. So
yeah.
the limit is x.
Except for the y one, it's 2. -2, 2. This one it's 1 and 3. No, 1 and 3, yeah. There we go. Alright.
It does not exist for the limit as x approaches
I'm gonna grab a snack
infinity.
real quick. Burn break. Dicks. But damn. Alright. A buy now. A lot now. Amidst. A lot. Oh, a line? Wordle 2. Wordle and 2. That's what I'm talking about. Let me see my gifts are. My gifts are safe. I'm not gonna hold you, bro. I might have some crazy gifts. Oh yeah. Oh yeah. We farming up Orla Egghead right now, bro. Or Eggman, my bad. Not Egghead. That's One Piece. Ooh. We farming up Orla Eggman, bro. Matter of fact, let me. What's that song at? What's it? You made my heart burn, and then it's like the. No. This one, I think. Yo, chill. What one was this? Hey, this is. I thought you had the Shibuya or something, bro. How long ago was this? Knock. You cannot call in to join your own stream. Wait, can I like raid someone? Can I raid someone big with just like one follower? Hey, bro, we're about to raid someone after I finish this. All right, let me tap in. Oh my days, I look like freaking a horror movie, bro. Oh, you just heard my bullshit, bro? Bro heard my bullshit. What the hell? We got 4 viewers, bro. Who was tuning into the stream, bro? Who was tuning? Yo. Type. I gotta type in, bro. I gotta do my math, but like, low-key, type in the chat if you're. Who is in the stream right now? There's gotta be 2 of my friends, bro. I gotta do math though.
X. So we'll start by combining the 2 terms into a single natural log, which gives.
Oh my days.
The limit as x approaches infinity of the natural log of 1 plus x squared
natural log of 1 plus x
over
squared.
1 plus x.
All right, hold up. Three viewers, bro. Who is watching this, bro? There's no way I can double. Who is the third viewer, bro? Well, I got tap. I gotta do my math. So we go from, we literally just put one on top of the other. All right, I get that.
But we know that the limit of natural log of a function is the natural log of a limit of the function. So we can express this differently as the natural log of the limit as x approaches infinity of 1 plus x squared
1 plus x
over 1 plus x. So now we can start to evaluate this limit within the parentheses. So since both the numerator and denominator approach infinity, in order to find the limit of the ratio, we need to divide both the bottom and top of the ratio by the largest power of x in the denominator. So we divide numerator and denominator by x. So this becomes the natural log of the limit as x approaches infinity of 1 over x plus x in the numerator divided by 1 over x plus 1 in the denominator.
Because x is the max thing we can divide by.
As x approaches infinity, the 1 over x terms approach 0, so these terms drop out, which leaves the natural log of the limit as x approaches infinity of x over 1, which is just x, which leaves the natural log.
Okay, this turns to 0, this turns to 0. X over 1. Is it just infinity over 1?
Of infinity. And we know that the natural log of an infinity is infinity. So this is the limit of the function. In summary, we evaluate the limit as x approaches infinity.
Oh, I'm slow. Okay, it still did explode back to 1. What the hell? Damn, I'm sick. Lim is x approaches infinity. Oh, anything over, I'm slow. Anything over 1 is obviously going to be whatever the top was. And then you just plug infinity in. Okay, that makes sense.
Natural log of 1 plus x squared minus the natural log.
Alright. Time for my ball crushing shift. Okay, so about the x. 6 over x. Over. Did I miss a step? What did I not do? Or whatever. 0 plus x over 0 plus 1 sine of infinity, right? Yeah.
Let P and Q be polynomials. Find the limit as x approaches infinity of P of x
15 seconds. Damn! I like the sound of that.
over Q of x if the degree of P is less than the degree of Q. If the degree of P is less than the degree of Q, then if we divide out the numerator and the denominator, by the highest power of x in Q, then the new numerator is going to 0.
What?
But the denominator does not. So we can say that the limit as x approaches infinity of P of x divided by Q of x is 0. Because after dividing out the highest power of x in Q of x, the numerator goes to 0. Let P and Q be polynomials.
Yeah, that was not helpful.
Find the limit as x approaches infinity of P of x over Q of x
This is just 0. Is this 0 the answer to both?
if the degree of P is greater than the degree of Q. If we divide the numerator and the denominator by the
What's up? What the dog doing? What the dog doing? Can y'all see him? I don't think anyone can see him. You two do not hear me.
highest power of x and Q of x, then if the degree of P is greater than the degree of Q, the numerator is approaching positive or negative infinity, depending on the sign of the lead coefficient, but the denominator does not. So we can say that in the degree of Q, the numerator is approaching positive or negative infinity. Of
my brain is not working.
P is greater
I actually need to slow this down.
than the degree of Q. Let P and Q be polynomials.
Okay.
Find the limit as x approaches infinity of P of x over Q of x if
PQ polynomials and lim as x approaches in infinity.
If the degree of p is greater than the degree of q. If we divide the numerator and the denominator by the highest power of x and q of x, then if the degree of p is greater than the degree of q, the numerator
if the degree of p is greater than the degree of
is approaching positive or negative infinity, depending on the sign of the lead coefficient, but the denominator does not. So we can say that the limit as x approaches infinity of p of x divided by q of x is positive or negative infinity.
What? Oh my god, my nose is stuffed.
Let p and q be polynomials. Find the limit as x approaches infinity of p of x over q of x if the degree of p is greater than the degree of q. If we divide the numerator so we can say that the limit as x approaches infinity of p of x divided by q of x is positive or negative infinity.
What? Which one had 0? Gang.
Let p and q be polynomials. Find the limit as x approaches infinity of p of x over q of x
I don't understand
if the degree
this.
of p is less than the degree of q.
Oh, I'm dumb. I can do. No? It's just infinity? I don't get it, but I solved it. Gotta count for something. I gotta blow my nose. Be right back. What's up, Zig? Oh, this guy ripped out my headset, bro. Oh my days. How do you even do this? What the hell? Oh, don't tell me it's fucking detached now, bro. Oh. Yeah, oh, it does work still.
Find the limit as x approaches infinity of the quantity the square root of x squared plus ax minus the square root of x squared plus bx. Here, the first step is to rationalize the numerator. We can think of this statement as a rational expression where this is over 1. If we multiply through and divide through by the conjugate of the numerator, then we rationalize the numerator. The conjugate of the numerator is the square root of by the conjugate of the numerator, then we rationalize the numerator. The conjugate of the numerator is the square root of x squared plus ax plus the square root of x squared plus bx. This appears in both the numerator and the denominator of this term. Multiplying out, this becomes the limit as x approaches infinity of the quantity x squared plus ax minus the quantity x squared plus bx.
Oh my god, I'm gonna die.
all over the square root of x squared plus ax plus the square root of x squared plus bx. Now we divide through both the numerator and denominator by the highest power of x occurring in the denominator, which is x, because we have the square root of x squared here. So we have the limit as x approaches infinity of the quantity a minus b times x divided by x over the quantity the square root of x squared plus ax plus the square root of x squared plus bx divided by the square root of x squared, which is equivalent to x when x is greater than 0. Simplifying, this becomes the limit as x approaches infinity of a minus b divided by the square root of 1 plus a over x plus the square root of 1 plus b over x. This term contributes 0 as we take the limit. So we have a minus b over the square root of 1 plus 0 plus the square root of 1 plus 0.
Okay, it's 1 plus 1, bro. Why are we
which comes out to a minus b over 2.
Oh my gosh.
This is the limit.
Oh my gosh. Holy crap. Oh my god, I'm in hell. I'm in hell. Fucking hell. Do these cancel out? Oh my god. God damn. Oh my. Okay, what happens now? X just cancel out? How does that work? S minus T. Over. Yeah, I don't get this. This is S minus T over 2, bro.
Estimate the value of the limit as x approaches negative infinity of the square root of the quantity x squared plus x plus 1 plus x by graphing the function. Let's go to our calculator. Here we graph the curve y equals the square root of the quantity x squared plus x plus 1.
Okay. X squared plus x plus 7. Looks like rise of 2, run of 1, 2. Yeah, I don't know. Alright, bruh. You're making
Plus x.
for nothing.
We notice that our curve is approaching, it looks like 0 on this graph, but we know that that's not the case. When we press trace and we trace it to the left, we're letting x get larger and larger to the left, which means x is approaching negative infinity. If we watch our y values, we can guess that our y values are approaching negative 0.5 or negative 1/2. So I would guess here that our limit as x approaches negative infinity, that the y values go to negative 0.5. Use a table of values of f of x to guess the value of the limit. Here we want the limit as x approaches negative infinity. So we'll start out with x values of negative 10,000, and we will let x get larger and larger negatively. So we'll try negative 100,000, and then we'll try negative 1,000,000. So sick, bro. Oh my god, I'm so close, but I'm so far. Estimate the value of the limit as x approaches negative infinity of the square root of the quantity x squared plus x plus 1 plus x by graphing the function. Let's go to our calculator. Here we graph the curve y equals the square root of the quantity x squared plus x plus 1.
What's x on here? Okay.
1 plus x. We notice that our curve is approaching, it looks like 0 on this graph, but we know that that's not the case. When we press trace and we trace it to the left, we're letting x get larger and larger to the left, which means x is approaching negative infinity. If we watch our y values, we can guess that our y values are approaching negative 0.5 or negative 1/2. So I would guess here that our limit as x approaches negative infinity, that the y values go to negative 0.5. Use a table of values of f of x to guess.
This is not helpful, bro. What the hell? Oh my god.
A tank contains 5,000 liters of pure water. Brine that contains 30 grams of salt per liter of water is pumped into the tank at a rate of 25 liters per minute. Show that the concentration of salt t minutes later is 30 t over 200 plus t. This is measured in grams per liter, and that will help us get this expression. So, after t minutes, we have 25 liters per minute times t minutes will give us 25 t liters of brine. Then we have the 5,000 liters initially of water, so our total liquid or brine solution will equal 5,000 liters plus 25 t liters of the brine that's added. Then we have to talk about the salt. So that's measured in grams. There's .30 grams per liter of salt being pumped in, so the tank will contain 25 t liters times 30 gram per liter, and the liters cancel, giving us 750 t grams of salt after t minutes. So putting all this information together, our formula, let's say C is for concentration at time t, so C stands for concentration, which is grams per liter. Our grams of salt is 750 t grams, and the liters, total liters, is 5,000 plus 25 t liters. And when we reduce that, that is 30 t over 200 plus t grams per liter.
Oh my gosh. What is the point of this? Holy crap.
Find the limit. The limit as x approaches negative infinity
Five times 40. What is that? $1K. Over 2,000 plus. Oh my god. circuitous. Oh man. It's 1/2.
What happens to the concentration as T approaches infinity? The concentration is given by 30T divided by 200 plus T, so we want the limit as T approaches infinity of C of T, which is the limit as T approaches infinity of 30T divided by 200 plus T. Now the numerator and the denominator are both degree 1, so we divide each term by T, and this gives us the limit as T approaches infinity of 30 over 200 divided by T plus 1. Now 200 divided by T will approach 0 because the denominator there is getting larger and larger and larger. So the fraction will get smaller and smaller. So this limit is 30 divided by 1, which is 30 grams per liter. So the salt concentration is approaching that of the brine. This is the original concentration.
Holy fuck. Oh, my days. Oh, Jesus. Alright, let me get this. Alright. Deltarune Chapter 5 will release on June 24th. Oh, shit. That's how I feel right now, bro. Invincible. Closed. I swear. I was like about Christmas, bro. Burnley. What the hell? I've got already those two, bro. Hold up. I didn't even realize he had a follow. What the hell? What the hell? Why does it say we did? Big scam, bro. Who's watching? Three viewers. Oh wait, this is probably on my monitor. It's probably Evan or something. Where's my Can anyone tell you families? Scrub. Damn. Yo, what did they do? Goofy, you mean? What the hell? Oh, hell no. It's Blue Bunny. What? Bartender, a beer, please. Tada. a sneeze. W wristband? Yo, she lives back there? I did not know she lived in a mansion, bro. What the hell? Bro, literally has a friend. Oh my days, what the hell? What a mansion. Study group. Yeah, we ain't doing shit, right? Wait, I just finished my study. Now I think about it. Ho, ho, home. Let's make the caption of that section. Yo, why did Toby drop this when it's like Christmas time? That's What is this? Yo, this is where the freaking next thing's about to take place. Damn. he slumped like that? Oh, this is freaking Dessa's room, right? Army rations. Shelter. What? How does Des have it? Whoa! What the hell? All right, well I have it freaking. It was either 122 or 123. I've got it on VOD, bro. You can't do shit, bro. I beat you fair and square. This is my perfect victory. Oh. Hey, stop! Stop! Yo! Oh, they really just not seeing this, bro. Oh my days! What? I knew this was a bad one, bro. Gang. Yo, Heart, do something. Let's go. Give me a new heart. Oh, yeah, yes, sir. Yes, sir. Huss. Huss. What the hell? Okay, that's a lot of let's go down first. Can't do anything. Let's go this way. Oh shit. Dark Fountain. Next. Susie must not get guitar. Mid soul. Yo, chapter 5 is about to go crazy, bro. Without soul. Chris will. Susie guitar. Code stop. Police sacrifice next week. Oh, undecided next week. All right. Church tonight. Oh. This dark world, no soul can't. Yo! He freaking knocked himself out? Bro. Oh, where am I going? Oh, he's awake now. Oh. Oh. So just keep on exploring up here real quick. What we got going on? What's he doing here? Concentrate. The bro's about to get a crazy state out or something. That's it for all. Yeah. That's it. Oh? What is going on in this house, bro? Can't do nothing. Oh, shit! Yo, I can't catch a break with this dude, bro. Let's go. I don't even know it's all the way up there yet, bro. Flowey. What's he talking about? Black Shard? Oh, wait, okay. That's, I think, how I escaped, though. Or not. Oh, back in Dessa's room. Can't do anything, though. This tongue, bruh. Oh, he locked it up. I can't escape from it. Why is bro playing the piano? Oh, I'm in the basement. What are these two? I'm out risking my life, and these two are just gooning, bro. Oh. Yo, I gotta hide, bro. The other guy's gonna come soon, bro. Yeah, I don't know where to hide. Can't hold you. I'm gonna get found by other me, bro. I don't know what I'm gonna start flying. Yo! Oh, it's over. She hates mice, though. Yo, it's over. Yo, I'm about to slime these two out, bro. Straight goonin'. Let me out! Yo! I'm gonna get caught. I can remove left or right. Get away from me. Oh, I can escape, right? Yes. Huss! Huss! Oh, I really could just do whatever I want. Yo! Yo! This guy's relentless, bro. Yo. that make noise? Yo! It looked a little like Azrael. Oh, Rousey. One, why? Again, I got so over I stopped questioning. Large city. Yo! Yeah, we got the freaking the guitar. Yo, I'm about to get harassed, bro. Oh my god. I'm gonna lose. What is that? Oh. Susie guitar. I'll be right there. Oh my god, I'm going to lose. Oh, I'm gonna lose. Oh! Why am I back? Why did you put me back in? What is going on? Yeah, but it does hurt. W Riz. What is he doing here, bro? Yo. Oh, she's a bitch. She's a bitch. Oh. Get your hands off the gut. Is she? Well, I'm piecing it together, guys. Damn. They're not welcome to me. Yo, Asgore, do something. Oh, that was What am I supposed to do? I'm just in this house, bro. Shit, is that for everything? Like, son. Oh shit. Yo. What is... Asgore, what are we doing? Lock in, Asgore. Holy shit. Whew. Says freaking. Damn, I feel like starting to rain. What was it saying? Ooh. What the?
When the light is running low.
Alright, bro. I know you chill like that.
And the shadows start to grow. And the places that you know
Come on.
seem like fantasy. When the light is running low.
Ah, bro, just feel she ass. Oh yeah. Okay. This place bumping. love this little town, bro. It's like, no way. Oh, he's tenor? That's tenor, isn't it? W Susie, bro. What is this? It's empty. W Susie, bro. I thought that almost said of course for a second, but thank God I didn't write of course not, Damn, this guy just is a freaking... Wedge is crazy. W Mally's way. Huh? I already did. At 1. So great after that. Damn, it feels so weak now, bro. Alright, let's go to the church. Oh crap, isn't the freaking light gonna show up tonight? I have a feeling this is going to be a lot more serious than it is happy-go-lucky the other games have been. Oh shit. Yo, Stan's about to spawn in, bro. Left, down, left. Left, down, left. Down, left. emu or something, bro? Jesus, bro. Straight conquers on me. Holy moly. Damn! Oh, yo! Listen. What the hell? God damn. I heard Rousey, bro. W Rousey, bro. Oh. Yo. Yo, I'm getting chills right now, bro. Who are these guys? Toby. Oh. Five to games. I'm the confused psycho. Choking too close. Both will keep the bars, bro. I'm going to head to the same team base and that boy. Yo, we about to see Sands, bro. Oh, Below, on hopes and dreams they send 3 heroes at the world's end. Yo, it's Gerson, isn't it? Oh, it's over. I don't like this. Gerson, boom. Balti has it. Yo. Probably like 7:30. I look, you might get off now. Well, actually, never mind. I can't say. If I was casting that, you would die. Just checking your reflex. Yo, I gotta. Shit. Oh, back here again. Basically, it's a story that told Kanye went to streamer's chat 0 viewers. And he messaged you want to be in streamer you, and he didn't look at chat. That's crazy. That's actually I should probably apply real quick before I go. I'm trying to save up. I'm gonna save it and I'm gonna show it to you. What the? Back to some shit about the way I put the music. This is better enough. God damn, let me just save, bro. I'm trying to hop off. Oh, I'm done now. Yeah. Alright. Let's see.
For
Yep.
And then his sister would take long on top of that, bro.
I mean, I would too.
Yo, am
Like,
I...
the only reason I got to school half the time was because my sister woke me up.
Is it time for the streamer
No,
university?
but he didn't. The thing is, he didn't want his sister to wake him up, bro.
Yeah.
And the thing with Evan is that it's literally a 1-minute drive, bro. I guess too, if you.
Yeah, I don't know. I was definitely a dickhead, but like I think trying to think back to it, the thing is like I didn't want to do it because like I'd pick up brick first, and then that would take. Obviously, brick would take forever, and then by then it's just a pain in the butt.
You pick up bread?
To pick you out.
Shit, you just have to start leaving him, bro. Hey, every time you pick me up, bro, I was ready, bro.
You know, it's just like, one for all and all for one.
One for all.
But also I didn't.
We are not doing that. Brooke does not deserve no all for one, bro.
Yeah.
And then at least Evan, I could understand because Evan would also pick up Arden's friend and Adriana. So like half of the time. Yeah, bro.
Welcome to our Adrian. Who describe our friend group?
Put in your YouTube, Nick.
Yes, bro.
Make YouTube your first one.
YouTube my first one. All right.
Because your Twitch has nothing on it, really.
You're right.
How can you see what bro's doing?
His stream.
Anyway, I forgot what I was saying. Yeah, so after the time he just couldn't.
Yeah.
He couldn't take me. Oh my god! Like I genuinely went through hell on that bus, bro. And that shit was always late as fuck. Damn, bro.
You gotta start streaming on TikTok.
TikTok? Do I buy a what's it called?
Damn, bro.
By what?
You really reminded me, bro.
What's it called? The premium for the streaming thing, so I could just stream on all 3 platforms, bro.
I mean, yeah, I mean, it's up to you.
How much is the premium?
I don't know, actually. Let's see.
Damn.
Free plan.
The thing.
Man, fuck you, bro.
Free.
Hey, well, one of these days, bro, I'm gonna get you back.
Me?
Hey, I drove you home. I did all this like.
Yeah. Now, bro, trying to cover, bro.
No, I'm just saying. Like, obviously, what I do was fucked up. And at the end of the day, I don't have no obligation to pick you up. At the end of the day, like,
it's not about obligation, bro. That's your friend, bro. Going through the.
Just because you my friend don't mean I
no.
want to pick you up every day. Come on now.
Up, bro.
Put in your LinkedIn, Nick.
I do it, bro. But I would do it, bro.
You can't put in your LinkedIn, I don't think.
Let's just see.
That's the difference, bro.
Yeah, you can't.
And that's why you a better person than me.
Banger YouTube video, y'all.
That's what I'm saying. That's fucked
Airport.
Up. I gotta get you back, bro.
Wait, Takashi, he really gonna fly you out, bro? That's crazy.
What?
Yeah, no shit. It's Streamer University.
Yo, that's actually hype, bro.
Hey,
nah, you
gotta
get
forget
there,
all
bro.
your day ones.
Oh,
I looked at the one. Yeah, this is looking.
This guy lives